In the previous section, we looked at the power of stories, along with the basic narrative structure and some well-known general story architectures. A truly effective story takes into consideration not only characters, scene, and plot details, but who the intended audience is. In the next segment, we'll examine what you need to consider when building a data story, both for you and your intended audience. Let's jump in. An effective data visualization places the content, the question you are trying to answer, and the data you are using to do so in the proper context, who your intended audience is, and what their knowledge and expectations include. Take, for instance, this visualization from Matt Daniels, which shows the number of unique words used in a rapper's first 35,000 lyrics. It's a great visualization in that it's clear what it is about, and it tells a story about which rappers have more prolific vocabularies, especially thanks to the extra detail Daniels added by comparing them to prolific writers such as Shakespeare and Hemingway. The true greatness of this visualization, however, depends immensely on whether or not you like rap music. If you do, the just Wu-Tang toggle next to artists and regions is going to give you a serious chuckle, and perhaps confirm some deeply held opinions you have. If you don't, then simply shows you that some rappers use more unique words than others. That is the very essence of context, which we'll get into more detail a little bit later. For now, let's look more closely at data as content. As a data analyst, your goal is to take a question and a potentially messy set of data and turn it into something that tells a clear, concise story to your chosen audience. Your data, that bucket of Legos right there, is your content for that story. And just like a writer has a huge well of words to choose from, you need to sort through, organize, and analyze your data in a way that helps you tell that story. Let's take a look at some of the things you need to know about your data in order to do this well. We cover some of these concepts in much greater detail in both the Introduction to Data Analysis and Data Culture courses, so we strongly encourage you to watch those if you haven't already. If not, don't worry, we'll explain things enough that you'll certainly be able to follow along here as well. Knowing what kind of data you have will help you think about how you'll visually communicate your results, as different charts and graphs are better suited to different kinds of data. Quantitative data describes the measurable aspect of things, facts like someone's height or the number of community members served by a certain program. Within that category, quantitative data can be discrete or continuous. The number of M&Ms you can count is a discrete value. It can only be an integer like 8, 10, or 250. But the weight of those M&Ms combined is a continuous value, in that it can take any value within a range, say 1.5 pounds or 30 ounces. Alternatively, qualitative data are described by subjective, non-numerical values, like the color of the M&Ms. The three types of qualitative data include binomial, which is an either-or category, if someone likes M&Ms or not, nominal, which is an unordered category, like color, and ordinal, which is an implied ordering of categories, like small, medium, and large bags of M&Ms. Understanding the scale or size of your data has broad implications. It will influence how much time you need to collect, clean, and analyze the data, which tools you might use, and how you'll represent the data. Smaller data sets require less of all of those, while data that reach into the realm of big data can mean significant commitments of time, resources, and visualization efforts. In our Introduction to Data Analysis course, we cover how to calculate and understand the distribution and variability of your data in detail. But for now, it's important to note that this information will strongly influence not only your analysis, but how you present the data visually. The same goes for the cardinality of your data, which refers to whether the data you are collecting will have a great deal of uniqueness, such as people's email addresses, or low cardinality, which is associated with binomial values, like gender or yes-no answers to a survey question. Data provenance is the documentation of the inputs, entities, systems, and processes that influence the data. It's a form of metadata about where the data came from and what happened to them. And this is just as important as the size, structure, and distribution of those data. The most magnificent analysis and conclusions are useless if you can't trust the data you use to get there. If the data didn't come from your own organization, be sure you know what, who did, and how they collected those data. Be sure to find out what colleagues advise about that organization and data. Does it have a good reputation? What are people saying on forums, community sites, and social media? Be sure there are reliable metadata associated with the data set, such that you can find out when the data were collected, by whom, if they've been updated, and how often. For this exercise, we'll have you take a look at some data from Chattanooga's public bike system. You can either download the data, or if you scroll down the page a bit, you'll see a blue button that says See Data, which will show you the table right there in the browser. Take some time to look around and take a note of the types of data you're dealing with: qualitative, quantitative, continuous, etc. The size and how this compares to other data you're used to working with, what you might know about its variability, and how to find out more, and the provenance of the data. Do you trust this source and these data? Spending time up front getting to know your data will save you time and stress later on, and set you on the right course for deciding how to communicate it.